G'day chemistry students, in this video we'll be looking at dot point 7.5.5. Our focus will be on surfactants, organic chemicals that can act as soaps or detergents. Let's get into it. So a surfactant essentially has two components. What is usually a really long hydrophobic tail and a very hydrophilic head. When we're using our prefix here, hydro, what we're referring to is water. Philic refers to loving or liking. Phobic refers to fearing. So we should be able to see that this head over here is hydrophilic. It likes water because of the polar bonds which exist, meaning that water is able to surround it and make this section essentially water soluble. In comparison, we have a hydrophobic tail, a non-polar organic tail, which is not soluble in water. A lot of the time, surfactants get drawn using a more simplistic representation. Rather than showing the functional group or functional groups at the end, usually we just show just a round ball, and then this classic zigzag pattern to show our hydrocarbon chain. So when these surfactants are in action, their main job is to form micelles. So assuming that we are using a water solvent, the tails of one of these surfactants should be able to surround non-polar dirt or oil molecules. If they can surround that, then essentially they are able to pick up the particle. Around the outside of this surrounded molecule are all of our polar heads, our hydrophilic heads around the outside. The water is able to come into contact with all of these and essentially dissolve the entire structure that's here. The structure being what we call a micelle. You can see that action maybe in a little bit more detail on this side here. So we have our first action where we have our detergent molecules which come into contact with our dirt or grime. All of the non-polar parts, our hydrophobic parts, are able to attach to the soil or the grime, which is non-polar itself. Again, that idea of polar dissolving polar and non-polar dissolving non-polar. So our non-polar parts surround our dirt and grime, and essentially they pick them all up and end up forming these small units. Now the soil or dirt or grime that is inside is not just one molecule large, it's a collection of soil molecules all surrounded by the surfactant itself. And again, we see that the part that is polar and is soluble in water is on the outside of the micelle. The water can then surround it and effectively dissolve it. What this means then is that we have a polar solvent which is capable of dissolving non-polar substances with the assistance of these surfactants. And essentially this is why we use soaps and detergents to, say, wash our hands or clean dishes. Most cleaning products have the main goal of being able to lift and remove non-polar substances so that they can be dissolved and removed with water. Now, water is a really effective cleaning substance because it is polar. It's able to dissolve a bunch of different substances that may need to be removed. Not only that, it's really prevalent on Earth. So because it's so common, it's so easy to acquire and use. The only disadvantage of using water is that there are a lot of substances which cannot be directly cleaned with it. This is where our soaps do come into effect. I have a couple of other diagrams which maybe show the insertion of our surfactants into our oils to form a micelle. I also want to identify that surfactants can be used to surround water, enabling water to be able to be dissolved in a non-polar solvent. This is a significantly less common phenomena, but it is certainly possible. We also have a bunch of different surfactants as well. So all of them should have a long hydrophobic tail, which is capable of picking up the non-polar substances that we want to be able to dissolve in water. But we can have a variety of hydrophilic heads. Some heads are non-ionic, meaning that they are only hydrophilic because of polar bonds. Some are anionic, meaning that the surfactant becomes a negatively charged ion in water. Some are cationic, which means that they become positively charged in the presence of water, and some are amphoteric, meaning that they are capable of doing both. And this actually means that they can dissolve a slightly larger variety of substances. Just included a table with some examples of these different kinds of surfactants and potentially places where they may get used. Our focus in class is partially going to be looking at some of these different kinds of surfactants and maybe look at trying to explain why each of these types of surfactants may have their own uses. So in summary, a surfactant is composed of a hydrophilic and as well as a hydrophobic chain. That chain is able to insert itself into small particles of non-polar substances, meaning that around the outside there is a polar component which can dissolve in water. This is what we call the formation of a micelle and is what allows water to act as a very effective cleaning agent, even with non-polar substances. And we also know that there are a bunch of different surfactants, which we're going to be looking at in a little bit more detail in class. Thank you very much, everyone. In the next video, we're going to be focusing on reaction flowcharts. This begins to pull together most of the core concepts that we've been looking at in this module, particularly around our types of reactions. But until then, have a good one.